This is a summary and critical analysis of Midgley et al.'s evaluation of B-stem for predicting lateral retreat on composite stream banks.
The authors start with an introduction of stream bank erosion and its issues. As you can see in the pictures, stream bank erosion is not very aesthetically pleasing. Not only this, but erosion causes high sediment loads and is one of the leading pollutants in streams. An understanding of this erosion can lead to better stream restoration efforts. While the authors did provide a literary introduction, I thought this was very limited. Further analysis of how previous studies have evaluated stream bank erosion would have provided justification for why the authors chose to use B-stem in this study. The authors chose to use the bank stability and toe erosion model, also known as B-stem. B-stem has multiple tabs where data can be entered. The first is the input geometry that requires data about the bank, as well as the bank layer thickness. The next is the bank material. Here, soil characteristics are entered under the bank model input data, and the jet results are entered under the toe model input data. In this case, the authors ran simulations using both the default parameters based on soil type as well as the actual measured values. The final input tab includes information regarding the vegetation and protection of the bank. The authors not only provided an explanation of B-stem, but they also included why they chose to study this model. There are very few previous evaluations using this model, and it can help gain insight on the parameters that affect lateral stream bank retreat that then can aid in stream bank restoration. The methods section included an explanation of the field data as well as a modified B-stem process. The field data included the jet erosion test as well as soil cores. There were two types of soil evaluated at the site, cohesive and non-cohesive. This resulted in the authors using a 1-hour and 24-hour groundwater lag respectively. However, no justification was given for the rationale behind the lags chosen. For the purposes of replication, it would have been good to understand the reasoning behind the chosen lag times. Something that was very useful in the methods section was the flow diagram provided for the modified B-stem process. I thought this was presented very well by the authors and was more effective than writing a paragraph about it. The main results from the study show that B-stem drastically underestimated the bank erosion in all scenarios, but was able to estimate the time of those bank failures. As you can see here, it appears that measured results occur after the simulated results. The authors explain this was due to a lack of personnel in obtaining timely results. While I understand this can occur, I thought this was something that could have been avoided in order to strengthen the results. However, the figures and tables throughout the article were able to stand alone and had descriptive captions. The authors also included several explanations of why the model resulted in underestimation, including inability to accurately measure parameters, assuming steady, uniform flow in B-stem, and inaccurately predicting the water table lag. The authors indicate the period of most significant lateral retreat, but do not provide quantification or rationale as to why this retreat was significant compared to other occurrences. This is something I think the authors could have improved. Overall, the paper was clear, concise, and the results were thoroughly discussed. The authors provided detail on the direction of future research. They believe exploration is needed in estimating erodibility parameters for non-cohesive soils. They also mentioned the need for B-stem to consider the groundwater, which is an existing project in the current version of B-stem, shown here.